So what I snuck into that last example is if I have two functions, f and g, and I'm looking for the area between them, the area between those curves, over a certain interval from a to b, then that area is going to be the integral of g of x minus f of x dx. And so important features are that whichever function is highest must be first so that the area will come out to be positive. Also notice it doesn't matter whether f and g go negative or positive over the interval. That doesn't affect the fact that if I do g minus f, I'm going to get the positive number. G minus f will be positive, right? Since I'm subtracting f, f being negative just makes that positive. And if f is positive, I'm subtracting a smaller number from a larger number, so I'm still going to get positive values. So as long as g stays above f, g minus f will be positive, and this area does not need to be broken up over the points where either f or g or both cross the x-axis. So it's just a nice straightforward integral. However, if the g and f trade places so that first one's on top and then the other one's on top, right? So in this interval from the a to whatever this point is, g is above f, and from this point to b, f is on top of g. Now I've got to break up the interval. So let's say this is a point C where the two intersect and they've traded, f and g have traded supremacy. They've traded whichever function is highest. So then the area is going to be the integral from a to c of g of x minus f of x dx. Now I could go and use the same sort of model as I did with the x-axis and say that when they switch places I'll go minus the integral from c to b of the same thing. You can do that, but it also makes sense to say, all right, over the interval a to c, g is on top, so g comes first. Then I'm going to add another area from c to b where the f is on top. So instead of changing the sign of the integral, I'm just going to change the order of the integrand. By the way, that's what the thing you're integrating is called, is the integrand. So f of x minus g of x. Notice how I've reversed that, right? Yeah, this thing that you're integrating, that's called the integrand. A lot of interesting language going on behind that. It's a Latin future perfect, I think, something like that. Future subjunctive, I can't remember. Anyway, so if the f and g change place, then I have to break up the interval from a to b. I have to break it at wherever point they intersect, and that gives me two separate integrals, one where g is on top and the f is on the bottom, the other where f is on the top and g is on the bottom. And of course, if the functions change place multiple times, I have to make multiple integrals, which brings us to page 396, number 14. Also part of your homework. Of course, you have odds for homework, so the related problem in your homework is going to be number 13, but we're actually going to do number 14 here. So here's the information you've given. You're asked to find the total shaded area. So I've just drawn it here, and so our shaded area is this, and this, and this, right? If you want, pause the video and see how you would set up this integral. All right, so what we're going to do is we're going to say that the area is going to be, now here's another tricky thing, is I know that this part, like you have to think about where are the intervals when each function is on top. So for example, from here to here on the x-axis, because the limits of integration are on the x-axis. So from -2 to whatever this point is, the negative x plus 2 is on top. Then from -2 to this point, the other function, the quadratic, is on top. And then from this point to this point, the linear is on top again. All right, so how, by the way, it looks like I shaded above that line. It's really only this part down here. That's part of that area. So one of the things is to know where this interval breaks up. And so this is, in some ways, it's kind of obvious. You can look at this picture and you can see that this intersection point is 2, 0, and you can verify that fairly easily. This one, it's an easy guess that the x is -1, but you can't assume that the x is -1. It might not be. So how do I know? I need to know where the intersection points are in order to know what my limits of integration are going to be. So how I find the intersection points, and that's a step in the process, is to find the intersection points. All right, so to find the intersection points, I just set the two equations equal to each other. So I say when is, I guess I should label this graph. This one's 4 minus x squared. So I just say when is 4 minus x squared equal to negative x plus 2. So that's an easy quadratic to solve. You can rearrange it as 0 equals x squared minus x minus 2. You can factor it x minus 2, x plus 1, and then you can solve that x equals 2 and x equals negative 1. And that way, we can be certain that this point where these intersect is negative 1. And also, although it appears to be the point 2, 0 where these two intersect, but it didn't have to be. So this tells us that x equals 2 is the other intersection point, that we know that's 2. So now we know how to break up the integral. We're going to say that our integral is the integral from negative 2 to negative 1 of negative x plus 2 minus 4 minus x squared dx. And I'm putting them both in parentheses. You only really have to put the second one in parentheses, but just for a sort of completion. That's this little area. And then I'm going to say plus the integral from negative 1 to 2, right? From negative 1 to 2. Where am I getting these limits? Negative 2 to negative 1. Boom. 1 to 2. The limits are on the x-axis, negative 1 to 2, negative 1 to 2. All right. Now for this second part, it's the quadratic that's on top, so it comes first. 4 minus x squared minus negative x plus 2. dx, all the integrals get dx. And then plus the integral from our last interval is 2 to 3, 2 to 3. This time the linear is on top, the quadratic's on the bottom. So I'm going to put the linear first, negative x plus 2 minus, so it's always minus because I'm looking at a difference between, the minus really is encapsulated in the word between. Between means difference, so it means you're subtracting. 4 minus x squared is what comes second, dx. All right, so when you go to do these integrals, it's going to be really helpful if you rewrite the integrands first, because there will be like terms to combine. So we can simplify this integral before we do it. That will be our next step.